Hey, this is Don from Padlock Technologies again. Got the black shirt on, starting fresh with the black shirt. Um, we are going to talk about a feature that not many people really know about. I haven't got a question on this, so that lets me know that nobody really knows about this feature unless you're someone like me that reads the documentation, kind of get into that ones and zero, really geeky stuff. But this is going to be about the firewall and the ZTNA policy. I bet you that you probably didn't know that you can actually do ZTNA on the FTD. Now, I've looked at all the next generation firewalls, or let's just call it what it is, current generation firewalls. They're all current generation. The next generation stuff is here now. Um, but I've looked at, Palos, I've looked at Fortinets, I've looked at checkpoints, I've looked at Juniper SRXs, but we're not going to call that next gen Juniper. Step your game up. Nobody has this feature on their firewall other than the Cisco threat defense. It's a great feature. It's very confusing because it's a lot of parts, but I'm going to explain the theory here. And then in the next video, I'm going to show you in the lab what it looks like. So let's get down to the theory. Go to the blackboard here. I like to do my titles. So let's go ZTNA on an FTD. So what does that look like? So let's put the firewall here. Now, currently, you can only use Duo or Azure. In my lab, I'm using Entra ID or Azure. I could use Duo, but it's easier for me to just create an application in Azure for this, right? So then you have your FMC here. You have your management and all that good stuff. And then let's say you have a resource over here, some type of web server or something. And this is 192.168.1.1. And then you have another application over here. Now, right now, this can only do HTTPS, so it can't be anything other than, 443 right now. Let's say this is another app, a web-based app here, a web app, or app web, whatever you want to call it. And this is 192.168.1.2. So you'll have your user over here, all right? And then you'll have internet. Now, you can also do this with an internal firewall as well. Doesn't have to be an internet-facing firewall. In fact, in my lab, it's a internal facing firewall. This is not going towards the internet. So don't think that you're stuck with the internet, right? So we're going to put Duo down here in the box. And then we're going to have Azure / Entra for your IDPs, right? That you can use to do the ZTNA function on here. Now, this is not really similar to ZTNA on Cisco Secure Access, because with that ZTNA, you can do web and you could do other ports like RDP and stuff like that. And if you have the ZTNA module, it will redirect your RDP traffic in secure access to the resource, whether you're using a backhaul tunnel or a resource connector. So this is not secure access way of doing ZTNA. This is the firewall FTD way of doing it. So let's say we'll give it some public IP addresses here. So let's say this was 200, 100, 11. This is 200, 100, 12. So what you would do is, and then we have this outside interface here that we're going to say is, 200, no, actually 200, 100, 11. Sorry about that. You don't actually need public IPs for this, right? Now, I got that confused with something else. So what the FTD is going to do is act like a proxy. Like if you ever saw like clientless SSL VPN, sort of the same thing, but not, right? The FTD is pretty much going to act like a proxy between the internal resources and the external resources, right? So you're not actually going to communicate directly to the web service here. You're going to communicate to the FTD. FTD is going to communicate to the resource. Resource is going to communicate back to the FTD. FTD is going to communicate back to you, okay? So that's the flow. That's traffic flow, data plane flow. Now, let's look how this actually works here from a theory standpoint. You're going to have a public FQDN that goes to the FTD's external interface. So let's say this web server app was web server dot, something.com. All right. So when you go to that, you are going to go to here. This is step one. Step two is going to go to the outside interface. And here's the key to all this. I didn't put this in because I wanted to show you what step three is. So, and this is very important because if you don't do this, it will not work. Down here, the FTD has to be able to resolve the internal IP address of, this FQDN. So, right. So what you're going to do is when you create your application, you're going to say, hey, the external facing URL is this, but the internal facing URL is going to, match to this IP address here. So the FTD now has to go to DNS. And let's say you called this from an FQDN standpoint. Let's say you called this web server internal.yourdomain.com. All right. So in the application, you're going to say, hey, the external IP address is what I'm looking for. And then I'm going to look for the internal resource using this FQDN. So this is why you have to now go to DNS here at the bottom. And DNS would say, web server internal.domain.com maps to 192.168.1.1. And then let's say you had another FQDN like web server 2, right? And then you gave this FQDN, web server 2 dot internal dot yourdomain.com. So then you would say web server 2 internal yourdomain.com goes to .2. So this is really the key in this whole setup here, because if you don't have that internal resolution happening, it doesn't know where to go from a proxy standpoint, because it's going to be listening on the outside for, hey, when I go to this URL, you're going to come here. And then it's going to say, okay, if you come here, from an application standpoint, it will say, if you come to this external IP address, you're going to, our external FQDN, you're going to resolve to this internal FQDN, right? And in order to do that, you need to have DNS to resolve that FQDN, because it's going to try to go to your local DNS. So that means you need to have your platform settings set up that says, hey, here are the internal DNS servers, and this is how you get here. If you don't set up, let's go over here. This is done through a platform setting in the FTD. And then once you have that, that will have your DNS group and all that good stuff. And then you say, hey, in order to reach it, you got to tell it what interfaces to use to reach it. So that could be an actual data plane interface, or it can be your management interface. Really depends on what you got going on. In the lab, I have it as you can get to it through the management interface, or you can get to a zone that says ZTNA outside. It's basically my zone. It's what you can get to, right? Because this is an internal firewall. Once that happens, what you're going to see is this usually is going, when it proxies on this port range is like 2000. It starts at 2000, and then I think it goes to like 2000. It's like a long 2000 number. So what you'll see is your web server dot whatever dot com will say web server :2000 whatever dot com. That's how you know you're being proxied here, right? Once that the proxy is working. And the best part about this is you can also do your IPS policy. You can have your malware policy, because it is doing inbound decryption. Now, remember, I did a video earlier about outbound and inbound decryption. The outbound decryption is when you don't know the server, so you don't know the key, you don't have the key whatsoever. So you have to decrypt and re-sign it with a known key that you have, right? So that'd be, something like SSLdecrypt.com going out to the internet. I do a man in the middle attack. I decrypt the packet, then I re-sign it with my firewall key. Well, in this, for ZTNA, you're going to use inbound decryption, which is, you have the cert and the key. So this is going to be decrypt with known key. So you think you're talking to the web server, you're actually talking to the firewall. So the firewall, use yellow again. So the firewall is going to present the key as if it was the web servers that you're trying to get to. So you think you're talking to the web server, but you're actually not talking to the web server. And that traffic is being decrypted. So it's going to be looking at that information that's going in. And this is where, IPS, your malware policy kicks in and all of that, right? And this is all in the ZTNA policy, or the zero trust policy that's in the FTD. Now, it is not in 742, I believe, because I am running 746. So if you want to take advantage of this feature, you're going to have to go to 746. But I have to give you the warning that 746 is not gold standard. So if you go to 746 and you start getting other problems, you already know what you're going to be told. Hey, you're on a non-gold standard image, right? So you may have to just deal with that until we either patch it, or they go to, I know 7.7 is coming soon, so they may just skip 7.6 and go directly to 7.7 as the gold standard. But this is the ZTNA policy on the FTD in a nutshell from a theory perspective. Trust me, when you see this stuff in the lab, it's a lot of moving parts, man. And the documentation is not as clear, right? So I'm going to break it down for you in the lab of what the ZTNA policy looks like. Why would you use this? Very simple. You don't want people to just directly go to your applications via a simple static NAT rule and an ACP rule, and then you just let traffic in. This is going to say, hey, you have to identify who you are before you even get to the application. So you have to log in before you get the login, which enforces the zero trust policy of never trust, always verify, right? So before you even get to see the application, you have to identify yourself to see my login page. And then after you get to that, you have to identify yourself again using whatever RBAC stuff you're doing. You have to now identify yourself again to actually log into the application. This is similar to ZTNA and Cisco Secure Access. If you use the web base or browser base or client base, you have to log in first before you even get to the application. So you have to identify yourself before you get to the application, then you have to log in again. The web base or browser base in Cisco Secure Access is they give you a link. You're going to have to now probably manipulate that link in your domain register to say, hey, go to this site, and then that kind of redirects you to this site underneath, and you just have to max the redirection so people don't see the actual long web URL, compared to browser base, which when you try to go to an application, you'll see something in your Cisco Secure client that says, hey, you need to log in first and identify yourself before we even redirect that traffic over to the application. And again, the key to all that is backhaul tunnels or resource connectors. None of that stuff works without actual reachability to the resource via backhaul tunnel or resource connector. With this, all you need is access to the FTD's external interface, and then you have to set up the ZTNA policy, which is going to now send everything to the FTD, and that's going to proxy that communication. Remember, this is only going to be HTTPS. Cannot do that with any other application compared to Cisco Secure Access, where you can, like I said, you can redirect or do ZTNA for RDP. I've already done that before. The other thing about this is you need to make sure DNS is set up correctly. So if you're doing this on a internal firewall, you need to now have DNS point to the internal firewall's interface, and then you have to have another record or a record that tells the FTD what the internal resource is that you're trying to get to. Once you have that all set up, this is pretty much solid and ready to go. It's pretty cool feature, man. Like, again, I have not seen any other next generation or / current generation firewall that has this feature. So if you want to take advantage of it, again, you need to go to 7.6. but this is something cool. And, I hope they keep this feature in there because, I can see a lot of applications for it. So this is Don from Padlock Technologies giving you the theory on the ZTNA policy in Cisco Secure Firewall. I hope this video was informative. Don't forget to share, comment, like, and subscribe. Thank you, and have a nice day.